Alright, back again. Once again, this is Mr. Spinks. We are on Section 2.1 in NAMS class, the third video of Section 2.1. Talking about some descriptive terms and some, ways to describe sets and some different features of them. Starting off, the difference between a finite and an infinite set is really simple. Finite set means it has a countable number of elements, okay? Physically can count the number of elements, 1, 2, 3, 4, 5. We can physically count them in this case. Whereas if we're talking about an infinite set, it has an endless number of elements, or an infinite number of elements. Now to make this simpler, I'm going to give you examples of each down here. So let's start with set A. And set A is going to be our finite set. Now to be finite, once again, has to have a countable number of elements. So A is going to be the set that contains 1, 2, and 3. That's set A. Notice, we can physically count the elements. 1, 2, 3. There are 3 of them. Whereas if we contrast that with set B, in set B I'm going to make an infinite set. Well, set B, to be infinite, has to have an uncountable number of elements. Has to have an endless number. They go on forever. They were infinite. So, to do that, I'm going to say set B is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and going on forever. And to indicate going on forever, I do the ... to the right. Now notice, set B is actually the set of natural numbers, a set that is not countable. It goes on forever, so it is an infinite set. Notice the difference between those two. Moving on, we are talking about this point in time about equal and equivalent sets. Now when we talk about equal sets, the equal sets are sets that have the exact same elements, not same number of elements, but the exact same elements. So let's write that out. Have the exact, same elements, the same ones, period. If one has 1, 2, 3, the other is 1, 2, 3. Exact same elements going on there. The difference between that and equivalent, sets that are equivalent just have the same number of elements. Pretty simple stuff. And we'll use an example down here to help you to understand this. When we're talking about equal and equivalent, let's start with two sets that are equal. Alright, well, to be equal, they have to have the exact same elements. So, set A is going to be 5, 6, and 7. And for the next set here to be equal to it, it has to have the exact same elements. So I'm going to say set B also has 5, 6, and 7. Notice how they have the exact same elements. This means they are equal. And therefore I can say that set A equals set B. Notice the notation on how I do equals, just an equal sign in between them. Let's talk about equivalent. Let's say I have set X. Set X is going to be 5 and 12. And set Y is going to be, well, it's a fun Y, is going to be, 23 and 32. Now, these are not equal sets, but they are equivalent because they have the same number of elements. They both have 2. So, to say that they are equivalent, I will say the number of elements of X equals the number of elements of Y. This is how we indicate two things are equivalent in this case. So we've done two things here. We've talked about the difference in between equal and equivalent sets and finite and infinite sets.